class. This is day one of recording videos for our online distance learning, whatever it is you want to call this time period. When we left off in class the other day, I had given you notes for section 8.3, so it might be a good idea to have those handy. They look like this: testing a claim about a mean. So kind of have those handy. And then I gave you the homework sheet for this section also. So have that handy. What I'm going to do is, rather than moving on to section 8.4 right now, I'll save that for maybe for the next video. I'm going to go through and do 3 problems out of the homework assignment, just so that we're kind of all on the same page before we move on to section 8.4. Okay, so I'm going to switch my screen over so that you guys can see kind of what I'm doing. Maybe if it goes. And what I'll probably do is, while I'm recording this video, I'll kind of embed some questions into the video, kind of like what your 2-minute test video did the other day, just so I can kind of check to see how we're doing, if we're understanding what's going on, and that type of thing. So just kind of be prepared for the video to stop, and we will get right on with it. If my screen will turn around. All right, let me try this. Aha, there it is. Okay, so when we left off on Monday, I think it was, I had given you this sheet, testing a claim about a mean. All the notes are done. Your formulas are on the notes, so kind of have him handy. Also, might be a good idea to have your T and Z chart handy. Let's see if I have those. I'll have to look them up on my computer, I suppose. And I kind of went through 1 through 8 and said what method that I wanted you to use. So on 1 through 4, I said that you can use the p-value method. And so we'll talk about kind of what that looks like. So maybe label those as PV, 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 PV. We'll do those as p-value method. And then on 5 and 6, I said use the critical value method. And then the confidence interval method is the kind of the, not really the new one that we learned, but the one that we're carrying over from chapter 7. So do that one on number 7 and number 8. Okay, so I'll do one of each of these with you. And there's kind of a typo on, I think, one of them. Number 5, I know, has a typo on it. So I'll do one of each of these with you, and we'll just kind of get on the same page and make sure that you, have all this information ready to go. What I'm going to do for this one, I think, is I'm going to do number 4 with you, just because some people might have already done number 1. So this will kind of give you a little bit of a head start for number 4. So this is p-value method. They're giving us a data set for earthquake depths, and I'm just going to write all the information off to the side. This is a really good idea to do so that you don't have to look back in the paragraph and gather it all back up again. So standard deviation 4.37, and use a significance level of 0.01. Okay. Now we do have to read the rest of this to kind of see what we're testing against. We're doing mean. Okay, that's the title of the section, and mean is searching for mu. Okay, so like proportion was searching for p, mean is searching for mu. So we're going to be comparing mu. So our null and alternative hypothesis are going to involve mu somehow, and so is our claim. Okay, so to test the claim of a seismologist, okay, that these earthquakes are from a population with a mean equal to 6. So we're testing that the average is equal to 6.00. So mu equals 6.00, and mu is not equal to 6.00. So in this case, our claim, think about which one that goes with, the null hypothesis, alternative hypothesis. Claim is going to go with the null. Okay, so whatever result we end up with for our null hypothesis is going to be the same for the claim. All right, now we did not get 6.00 as our average when we collected data from these 500 people. We actually got 6.39, but what we're saying is is 6.39 close enough to 6 to say that, okay, we'll give you that 0.39. That's not that big of a difference, okay? So that's kind of what we're looking at here, all right? So we're doing p-value method. So here's my 0% and here's my 100%. And then we've got to figure out where our cutoff mark is, okay? So since we're doing equal to, we've got two tails. I'm going to shade both of them, two tails. And then we need to figure out what percent is in each one, okay? We have 1% is our alpha, which means we're splitting that up into two equal pieces, 0.5% for both, okay? Still going to be 99% in the middle, and because our n is bigger than 30, we're going to use the z-chart. Let me look at the z-chart here real quick so you can have that on your stats. Let's see. What do I want? Z-table. Oh, no, we're not either. Not yet. Just wait a second. We'll figure that out here in a second. I'm going to do 0.5% here, and this would be, if that's 0.5% there, this would be 99.5% is where that cutoff mark is. Okay, we got to do our test statistic first since we're doing p-value method. Okay, so I'm getting ahead of myself. Test statistic. Formula for test statistic is this guy. How lovely. T is equal to x bar. Which one is x bar? Well, I guess it gives it to you over here. 6.39. Next piece that I need is mu, and mu is what we're comparing it to, so that's the claim, that's -6. And then it's standard deviation, 4.37, divided by the square root of 500. Okay? All right, practice typing that into your calculator. See what you get. 6.39 minus 6 divided by 4.37 divided by the square root of 500. All right, I got 1.996, which actually, if we go to two decimal places, is going to round up to 2.00. So that's what my test statistic is going to be. Now, I'm going to look it up in the table. And since our n is bigger than 30, we're going to look it up in the z-chart. Okay, and it's a positive number, so I need positive z-scores. Okay. All right, plus. So we want to look up 2.00. 2.00. Yep, first column. 0.9772. Okay, so 0.9772, or 97.72%. We've got to figure out where he lives in comparison to the rest of it. 97.72% is going to be real close to 99, but not quite in the critical region. Okay, so if I get this as a result, what does that mean? That means that we are failing to reject this. So we fail to reject the null hypothesis, which means we're saying the null hypothesis is okay. And what does that mean about the claim? Claim is valid, since we're failing to reject this, which means we're saying that this is okay, we're saying the claim is also okay. So even though we got 6.39 as our average, we're saying, okay, that's close enough to 6 to be all right, okay? So p-value method, that's what he's going to look like, okay? All right, never mind. Okay, let's go to the back side. Let's do number 5, because number 5 does have a typo in it. I don't know why when I typed this out, it did 64.1 twice. Okay, so if that's a question that maybe you had, there's the clarification for that. I don't know if it did that anywhere else down below, but if it ever prints that off twice, that's what happened to that. Okay, all right, a simple random sample. So number 5, this we want to do the critical value method. Okay, a simple random sample of 10 pages from a dictionary is obtained. N equals 10. All right, the numbers of words defined on those pages are found with the result of N equals 10, and we just wrote that down. The average number of pages on each, or number of words on each page was 64.1 words on a page, okay? With a standard deviation of 16.4 words, okay? So maybe sometimes it was in the 80s, sometimes it was in the 50s, whatever. Given that this dictionary had 1448 pages with defined words, the claim that there are more than 700 pages of defined words is equivalent to the claim that the mean number of words per page is greater than 48.3 words. Blah, 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 blah. That's a lot of information. What the heck does that mean? Okay. The whole idea of telling you that given that this dictionary has this many pages and 70,000 words, they're just saying that averages out to 48.3 words per page. So they're giving you this information. You really don't need it. They're giving you this information. You really don't need it. Because what they've just done to find 48.3, 48.3 is equal to 70,000 divided by 1448. Okay, so that's why they give you those numbers. They're just showing you where the 48.3 comes in. Okay, and 48.3 is the number that we're comparing to. This is the claim. So we're claiming something about 48.3. Okay, we'll talk about what he's doing here in just a second. So we know that this is 48.3, and we know that this is not equal to 48.3. Okay, so what is our claim saying? Claim that the mean number of words per page is greater than 48.3. Right, so mu is greater than 48.3. That's what we're testing, right? Now, our number was, in fact, greater than 48.3, but is it greater enough than 48.3 to say that that's actually greater than, or is 64 close enough to 48.3 to say that those two numbers are equal to each other? Okay, so you can kind of put in your mind what you think you're going to do for your accept or reject type of thing right now, but we'll find out exactly what's going on. So, significance level, 0.05. Greater than 48.3, what does the result suggest about the claim that there are more than 70,000 defined words? Okay, so let's figure this out. Greater than means we're doing one tail. And what percent will be in that tail? We're going to devote all 5% to there. And then there's going to be like an imaginary 5% over here, which means that we have 90% in the middle. All right, now we need to figure out, since we're doing the critical value method, we're not doing a 0% and a 100%. We actually need to figure out where this cutoff point is and this cutoff point. Really just this one, because that's all that we're concerned about, is the right side tail. So figuring out what that is, in this case, we're going to use the T-chart because n is 10. So we have less than 30. All right, so I'm going to go to my other chart over here. T distribution. Okay, plus. Okay, we want a 90%, and you guys all have this labeled really nice. How many degrees of freedom will there be? If n is 10, we'll have 9, and we want to go to the 90% confidence interval, which should be, I gotta think for just a second, area in to this one right here. This is 90%. It's the second one from the left, and we want to go to 9. Let me keep track of this. 9 right here. 1.833 is the number that we want to use. Make sure that's right. Yes, 1.833. Okay, so that's going to be our cutoff mark. 1.833. That's the number that we need. All right. Now we just need to do our test statistic, compare, and that's it. Okay, so same formula as before. We have x bar minus mu, so 64.1 minus 48.3 is our mu. Square root 16.4 divided by the square root of 10. Okay, and we can type them all in, see what you get. 64.1 minus 48.3 divided by 16.4 divided by the square root of 10. And I got 3.05. Okay, and then we have to figure out where he lives. Okay, 3.05 in relationship to 1.83 is all the way over here. Okay, so that means that we are rejecting this. We are saying our 64.1 that we got is not close enough to 48.3 to say that they are equal. He is definitely greater than 48.3. So for a result, I'm going to put off to the side over here, we are rejecting that. Okay, that the null hypothesis is true. Which means, what about the claim? Claim is valid because the claim is going with the alternative hypothesis. Okay, so the claim is still valid even though we're rejecting the null hypothesis because those two didn't go together. Okay, all right, last one. Let's do, we'll do number 7 together. Sure, this is the critical or confidence interval. Okay, confidence interval method, we want to figure out where mu lives between. Okay, and mu is going to live between x bar minus the error and x bar plus the error. And the error is calculated by the z of alpha over 2. And I think we always use z. We never use t for confidence interval. Z of alpha over 2 times the square, no, that's not right, times s over the square root of n. That's over the square root of n. Okay, so that's what we need. We just need to construct a confidence interval, write out what our claim and null hypothesis and alternative are, and be done. All right, so use a group of students estimated the length of 1 minute without reference to a watch. Oh, this is fun. If I was in class, I'd actually have you guys do this. If you close your eyes and then you set a timer and you estimate how long 60 seconds is, do you think you could hit it on the nose? Like, do you think you could hit 60 seconds on the nose? We had one person in here said, okay, it's been 60 seconds, and it was actually only 48 seconds. We had somebody that said, counted really slow or must have, and thought 102 seconds was equivalent to 60 seconds. Like, their measurement of 60 seconds was actually 102. So kind of an interesting deal. All right, so we're claiming, let's see, use a significance level, I'll write that down over here, of 0.01 to test the claim that these times are from a population with a mean that is equal to 60 seconds. So we're going to say that each one of these guys have an average that is pretty close to 60 seconds. Okay, we really don't know what the average is exactly. We really don't know the standard deviation, and then we need to know what n is. Okay, so n, how do I find what n is? Okay, n is going to be from how many numbers do we have all together, right? So let's see, we tested, it doesn't say, let's count them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. 15 people for n. Okay, even though that number is less than 30, we always use z for confidence interval anyway, so just don't worry about that for right now. S is going to be the standard deviation, and then we need to know the average of those numbers. Okay, so this is where my handy dandy computer is going to come into play, because I am going to take my spreadsheet out and I'm going to type these numbers in. Okay, and then I'm going to have it find the standard deviation for me. So 80, 91, 48, 76, 52, 31, 68, 71, okay, that's what it is, right? 80, 91, 48, 76. Okay, so equals, I want the average of those. Go back. Average. Okay, and then I want the standard deviation equals STDEV. Have the same set. All right, so average, I have 72.2, and standard deviation, I have 19.05, let's say. All right, so now confidence interval. I'm going to do the error and I'm going to calculate him over here. Okay, so I need my z of alpha over 2, and this is where we need to decide. Let me go back to full screen here. This is where we need to decide what z of alpha over 2 is. Okay, so we're saying a 0.1 or a 1% significance level and equal to. Okay, that means I have two tails and I'm separating the 1% into two pieces. So I have a 0.5% and a 0.5%, which means he's going to be 99% inside of here. So from z, I need to look up what 99% is, okay? So z at 99%, let me go back, positive z-score table right here, down here at the bottom, 99%, 2.575. 2.575, 2.575, negative. So 2.575 times s over the square root of n, or I should have put s in there, 19.05, and the square root of 15. That's what we need. Okay? All right, let's figure out the error. So oh shoot, I put one too many parentheses in there. Okay, there we go. Did that right? Square root of 15. Yeah, that's a huge number. Enter. Okay, so the error is 12.67. Okay, now we need to, last thing, construct our confidence interval. So I'm going to take my average, I'm going to add the error, and I'm going to subtract the error, and I'm going to write out what he is in the middle. I'm going to do this in a different color. So add and subtract. My average was 72.2. So 72.2 minus the 12.67 is 59.53, and plus is going to be 84.87. Okay, so now, last thing I need to do is to decide what that means about this guy. So does that mean that my average is equal to 60? We're saying that the average is some number that's between 59.53 and 84.87. So what does that mean about my null hypothesis? Or yeah, my null hypothesis. That means we're going to take that guy and we're going to fail to reject, or we're going to accept that that is true. Because 60 lives in my interval, he's going to be a fail to reject, which means the claim is valid. Claim is valid. Okay? All right, so there's 3 examples. You have now like 5 problems. 5 problems left to do. I'll probably give you today and tomorrow to work on those before I post the next video. So get that done. And what I want you to do after you are done with that is take a picture of your completed like homework assignment, probably with your phone or something like that, and then email that to me or text it to me if you have my phone number. Some way of getting that to me. Okay, and that is all I have.